In proposition 15, we're going to prove the equality of vertical angles, which are angles made when two lines intersect on opposite sides. So to the text, if two straight lines cut one another, they make the vertical angles equal to one another. And let's check out the setup. For let the straight lines AB and CD cut one another at the point E. So we'll draw this out. So let's say this is our straight line AB. And this is going to be our other straight line CD. And I'll label those AB and CD. And they cut each other at the point E. Then the claim is that the angle AEC, which is this one right here, is equal to the angle DEB. So he's claiming that these two vertical angles are equal. And we'll proceed to prove that. For since the straight line AE stands on the straight line CD, making the angles CEA, that's this one, and AED, that's this one. Therefore, the angles CEA and AED are equal to two right angles. And we've proved that already. That's proposition 13. So those two are equal to two right angles. Again, since the straight line DE stands on the straight line AB, making the angles AED and DEB, these two angles, AED and DEB, are equal to two right angles for the same reasoning. Notice that in those two pairs, they have the angle AED in common, and that's going to lead into our next phase of the argument. But the angles CEA and AED were also proved equal to two right angles. CEA and AED are equal to the two angles AED and DEB. And the next phase is let the angle AED, that's this one over here, AED, be subtracted from each of those pairs. And from that we infer that the remaining angle, CEA, is equal to the remaining angle, BED. So we're just going to subtract away that angle, AED, leaving only CEA and BED. And we use common notion number 3, which is that equals subtracted from equals will generate equals. And the generated equals are those two vertical angles. And he says, similarly, it can be proved that the angles CEB, or CEB, that's over here, and DEA are equal by a similar argument. And you can do that on your own as an exercise. It's going to be a very similar argument.